Howdy, students. Time to continue our tour through exponential growth. I hope you're as excited about this as I am. Probably not, but anyway, let's start with a thought experiment. Imagine there's a big lake and you put a lily pad on the lake. The lily pads reproduce, and each year the area covered by lily pads doubles in size. After 40 years, the entire lake is covered by lily pads. So the question is this: if it takes 40 years for the lake to be completely covered, how long does it take for the lake to be half covered? Now, pause the video, think about this, and then when you have an answer, restart the video. To get the answer, all you have to do is remember that the lily pads double in size every year. So if it takes 40 years for them to cover the entire lake, then they must have covered half the lake 1 year earlier. So the correct answer is 39 years. Now I'm guessing a lot of you said 20 years. You probably use logic like this. We know the coverage in year 1 was near 0, and we know there was 100% coverage in year 40. Then in your mind does what I call linear thinking. It draws a straight line between these 2 points. Using this mental model, you arrive at the wrong conclusion, that the lake is half covered at 20 years. The problem with this is that the growth here is not linear, it's exponential, and here's what it actually looks like. This is a lot different from linear growth. As you can see, most of the growth occurs in the last few doubling periods, with half the lake being covered in just the last year and 97% of the lake being covered in the last 5 years. Now, the human brain does a great job with linear growth, but does a terrible job with exponential growth. So let's talk about one consequence of this problem people have envisioning exponential growth. Let's imagine that at the end of year 35, you go to the local government, you show them the data up to year 35, and you tell them that we have a lily pad problem. The lake is going to be covered soon. They're going to look at the data, and they're going to tell you you're crazy. After 35 years of growth, the lily pads are only covering about 3% of the lake. It's going to be centuries before they cover a significant fraction. You see what's going on, right? They're engaging in linear thinking. If it takes 35 years to cover 3% of the lake, then it's going to take a very long time to cover the entire lake. But exponential growth blows linear growth out of the water. The growth in each doubling period is equal to the total growth in all the previous doubling periods. In this case, the growth during year 36 is equal to all of the growth that's occurred in years 1 through 35, and so on, until the lake is covered in year 40. So this is the first lesson. Future exponential growth is going to be a lot faster than past growth, and a lot faster than you might expect. Because of this, there's a tendency for people to underestimate future exponential growth. The second rule is that on a finite Earth, in almost all cases, there are limits to growth. Combined with fast exponential growth, this means that the end is probably closer than you think. That's certainly the case with the lily pad example earlier in the video. In year 35, even though the lake was only 3% covered, you were just 5 years away from the lake being completely covered. The book has several more examples, so make sure you read and think about those. Now, there are lots of examples of this, so I'll tell you one example from my life. In the early 2000s, I was working at the University of Maryland. At that time, housing prices in Maryland were shooting up. Here's a plot showing the house price index, and you can see it was rising rapidly. We can put an exponential line on there showing that the housing prices were indeed rising exponentially with a doubling time of just a few years. Now let me repeat that. The price of a house was doubling in just a few years. The housing market was in a frenzy. People who didn't own homes were scrambling to buy houses. When a new house came on the market, people would bid $10,000 over the asking price because they had to get this house. If they didn't, then by the time another house like it came onto the market in a month or two, the house might cost $20,000 or $30,000 more. In addition, real estate seemed like a sure thing. So you had speculators moving into the real estate market with the idea that prices would go up and up and up, and they could sell the house in a year for a huge profit. So that meant there were a lot more buyers, which further drove up the price. Now, had I taken this class, alarm bells would have been ringing in my head. The reason is that this rate of growth is unsustainable. If we extrapolate this rate of growth out a decade, in 2010, the price of a house will be 10 times what it was in 2000. That means a $200,000 house in 2000 would have grown to $2 million in 2010. This cannot happen. There's simply not enough people who can afford a $1 million house to allow the market to do this. So prices cannot rise like this. So what did happen? When the market started to go down, people who had rushed into the market suddenly realized that the real estate they were fighting to buy was actually worth a whole lot less than they thought it was, and the market crashed. This is a pattern we see frequently with exponential growth. The growth is so fast that the system overshoots the fundamental limits on it, and then when it adjusts, it crashes. So let's apply this to something of consequence: population. The population is now about 7.5 billion and growing at about 1% per year. So the doubling time is about 72 years. At that rate, in 72 years, we'll be at 15 billion people, and in 144 years, we'll be at 30 billion people. Given that 7.5 billion people alive today are severely stressing the planet in so many ways, 15 billion people seems like a stretch, and 30 billion people seems completely out of the realm of possibility. So it seems very likely that in the next few decades, within your lifetime, population on the Earth will peak. To me, the more important question is what happens next. Have we overshot, meaning that the population will then crash, or will the population gently level off to steady population? A population crash, if it occurs, would be a terrible thing to live through. It would be socially and economically destabilizing, and we should very much hope that doesn't happen. And now, your moment of dog.
Yeah, I don't know. I mean, I'm not sure if it's the new
group of people that's doing it?
Yeah, I don't know if it's the new Omicron that's...
Yeah, just stop everyone in their tracks.
That's
Yeah.
right, nobody wants to, because I know New York has now canceled a lot of stuff.
Right.
Yeah.
Broadway, Rock House, all that
Right.
stuff is now canceled.
In hindsight.
And we just read a lot of schools that we were just nearby us that they've gone virtual.
Yeah, they're kind of in segments right now, like Springfield is counting in there.